part B.3, average efficiency. In this part, we will do analysis for the average efficiency of the linear search or sequential search. All right, so that's our problem. All right. First, let's look at all the cases here. Remember our assumptions we did in the previous video. Here, we just use them directly. All right. Regarding the average efficiency, that's actually weighted average. We do the average, but the precisely the average is weighted average. How do we do the weighted average? Yeah, we will see. We will use those probabilities for the weights and do the average. All right. Two-step calculation. Because here we have two cases. Remember? The index case and the -1 case. Two cases. So for those two cases, we do two-step calculation. The first step, we calculate subcase average. For each subcase, we can do an average. We can find its average. So that's relatively easy. After that, then we combine those averages for subcases, doing the weighted average, then we get overall average. Those two steps. Yeah. Let me show you how to do it in this example. All right. Okay. All right. So let's do the average within the first subcase. Yeah. Now we use our assumption first. First assumption. Same probability, right? Each case, yeah, so, here. Each case, 1/n probability. Yeah. So that's our reasonable assumption we made in the previous video. All right. Then the average. So you add up all the numbers divided by n. Or you can do this 1 times the probability, 2 times the probability, n times probability, adding together. Yeah. So you can view it in different ways. One way is because they have the equal probability, you can add all these numbers up divided by the total number of cases. That's one way. Another, because the probability is this, so number times probability, adding together. Okay? Both ways, you get the same answer. This is the answer. Okay. All right. After that, what is the average of the second case or subcase? Yeah. Because the second subcase only, there is one possibility. And so you take the average of one possibility, still that one. Yeah. So we get the same number n for the second subcase. Then the probability for the first subcase and the probability for the second subcase, P1 minus P. Now we do the weighted average. This P is the first weight, W1, weight 1. This 1 minus P is the second weight, W2. Things like that. Then we do weighted average. Okay, yeah. All right. So we combine two subcase averages based on their probabilities or weights. Yeah. The probability corresponds to the weights. Okay, corresponds to the weights. Yeah. Okay. So the weighted average equals this formula. Okay? The number of comparisons times weight, okay? W1. The number of comparisons, the second subcase, times the weight number 2. Okay? Yeah. So that's the formula. All right. So after that, at the end, I want to talk about another important terminology in our efficiency analysis. Later, we will use it a lot. Okay. That terminology is the dominant term. Look at the dominant term, yeah, because here we have a expression. In this expression, remember, the n corresponds to the data size. N is the data size. Since it is the data size, it could be a large number. 1 billion, 1 billion, all possible. It could be a large number. Okay? Then for other numbers, 1/2, 1, and even this p. Even this p, after it is given, it is fixed. So we treat it as a constant number. Okay? So for all other numbers, it's a constant number. So now, when we talk about the dominant term, yeah, because here, there are several terms, right? N is the variable, right? Everything else is a constant, all right? So we may have a constant C times N plus another constant D, okay? Yeah. This D, the constant, never change, all right? C, constant, never change, but N can change based on the number of items in the data. Yeah. All right, so that's how we say this N. This is the dominant term. This term, dominant, the second term. It's a dominant term. So we drop this D part. This is our dominant term. Okay, so that's the concept. All right, so when we get here, all right, because this 1 times P and then times 1/2, that is that D. Okay? Because that's the corresponds to the constant part. All right? Then the C part. What's the C part? C part, you can see from the first term, what's the C part? We need to take 1/2 P also times 1/2 times N. So then 1/2 Pn, also the second term plus 1 minus P times N. Okay? So we put these two numbers together, that's the C. Okay? Together, 1/2 P plus 1 minus P equals 1 minus 1/2 P. All right? That is the C. Okay? So let me clear it out and put the final answer here. All right, because we ignore that plus 1. That contribution is too small, minor term, so we can ignore the minus 1 P. Yeah. So the dominant term is this. Dominant term is this. Here, we did a little bit algebra. So I hope you have no problem doing this kind of algebra. Okay? What I wrote before, yeah, I hope you can follow. Yeah. Yeah. I did pretty fast. I hope you can follow. Okay? Yeah. All right. That's the answer. And we finish this video. B.3.